We have chosen offshore pipelines as the asset to be studied for decommission as they are the vital components of subsea transportation system to transport common products. According to statistics done in United States, a total number of 982 incidents occurred throughout the year from 2010 to 2020 due to different factors related to pipelines. With that, it is important for us to understand the procedures, regulations, costs and risks involved during the decommission of pipelines.
Before we move deeper into our topic, let me explain what decommissioning of asset means. Every asset, including pipelines, has its own service life. Decommissioning means the process of officially removing an asset, no matter whether it's tangible or intangible, from service. Some of the reasons to decommission a pipeline are due to the aging of the physical condition, exhaustion of the oil and gas in the service place, and the expensive repair costs. Generally, the decommissioning process are costly due to the complicated procedure to secure the community's health and mitigate the environmental impact. Next, the decommissioning procedure of offshore pipelines usually include abandonment in situ, on-site preservation, and pipeline retrieval. Abandonment in situ or abandonment in place is a process of leaving an inactive pipeline in its installation area with no intervention after the end of its service life. It is suitable for the pipeline under the seabed at least 3 feet below. Some corrective measures have been taken, such as adding a rock dam and building a fishery exclusion area around the pipelines left in place to reduce the risk from fishery interaction. For pipeline retrieval, an offshore pipeline is removed from its installation area. It is suitable for the pipeline under the seabed less than 200 feet or with a small diameter. There are different cutting techniques, such as using a water jet, hydraulic shearing machine, diamond wire cutter, or guillotine saw. Excavation may be needed to remove the pipeline if the lifting force is insufficient. Moving on to on-site preservation. It is a process of leaving a pipeline on-site with continual preservation for future reactivation. Next, I will explain the decommissioning procedures. First of all, advanced planning is essential to ensure the process is done safely and systematically. After that, the pipeline needs to be isolated by physical removals such as air gap or water gap. It also needs to be de-energized from all energy sources. Next, the pipeline needs to be cleaned through the picking process to remove and recover all fluids according to the waste management plan. The following step is to close the subsea valves on the side tab and remove all appendages such as the valves and subsea assemblies. After that, the pipeline is cut near the platform's base before removing, and the tube turns are brought 3 feet below the seabed. Before cutting the pipeline, make sure it is flushed, depressurized, and free of hazardous materials. Then, the next step is to install fittings and caps and open the side tabs. After that, the riser and pertinent equipment are removed. The flush water and pipeline materials are also transported to the onshore site for disposal. For the pipeline left in place, it is recommended to install monitoring equipment or system to assess the long-term behavior of the pipeline. A post-decommissioning environmental survey can also be conducted to monitor the seawater quality at different locations. Lastly, during the decommissioning process, all documents must be recorded for future review purposes.
Moving on, we are looking into regulations imposed for decommissioning of pipelines. Legislation and regulations for decommissioning of pipelines are studied in 4 countries: Malaysia, United Kingdom, Norway, and United States. In Malaysia, no specific governing regulations for the offshore decommissioning and only addressed under national legislation. Having the ownership of petroleum resources, Petronas is responsibility for upstream facilities decommissioning based on PDA Petroleum Development Act 1974. On the other hand, implementation of the decommissioning plans would have to comply with the following legislation and standard as stated. Firstly, is the Merchant Shipping Ordinance 1952, which ensure the safety and take control over offshore industry structures, mobile units, and vessels. Secondly, is the Continental Shelf Act 1966 that stated the disposal of disused continental shelf and installation. Third would be the Exclusive Economic Zone Act 1984. Other regulations implemented for the decommissioning of pipelines are shown as above. The Petroleum Act 1998 in the United Kingdom stipulates that the owner of facilities and pipelines are compulsory to seek authorization from the Secretary of State for their decommissioning plans. Proposal to place associated materials on the seabeds require a license under the Marine and Coastal Access Act 2009 in England and Wales or the Marine Act 2010. In Norway, disposal of pipelines and cables on the Norwegian continental shelf is covered by White Paper 47. In the United States, the Federal Energy Regulatory Commission's FERC regulates and controls every prospect of active pipelines, operations, and decommissioning.
In this section, I will go through on the costs involved in decommissioning a pipeline. Generally, the cost drivers involved are the mobilization, rigging up, flushing, plugging, cutting, rigging down, demobilization, weather contingency, work provision, and the project management. The table below shows the cost estimate for the selected offshore pipeline in the Gulf of Mexico. Now, I will explain the cost factor that influence the decommissioning cost. First, a complicated project will be more costly because it will take longer to complete the project. For example, the decommissioning of the 32,900 mile pipeline by using the barrier approach is expected to cost $1.6 billion. However, the cost will increase by more than 900% if the complicated removal approach is used. Second, the decommissioning cost will increase with the pipeline diameter and length, as a higher flushing volume is required to clean the pipeline. Third, the deeper the pipeline is located below the water, the higher the cost for the mobilization and the diving activity. Fourth, oil line transporting crude require higher cost than the gas line, as more peak run and flushing volume is needed. Without further ado, I will present the cost estimation for the decommissioning of the Auger oil pipeline, which is a 174-mile offshore pipeline system in the Gulf of Mexico. This pipeline system consists of two pipelines with the diameter of 12-inch and 20-inch respectively. So, by using the table shown previously, it's estimated that $176.08 million is required to decommission the pipeline in the year of 2004. Taking the inflation into account, the 2004 value will be around $250.28 million in the year of 2021.
Risk management is an important element during asset disposal. Before we know how to manage the risk, we should know what is risk. Risk is unplanned event that is possible to take place. There are 4 steps in risk management, and these 4 steps are all applicable to manage risk during offshore pipelines decommission. Step 1, risk identification. Step 2, risk quantification. Step 3, risk response, which includes risk avoidance, risk sharing, risk reduction, and risk transfer. Step 4, risk control. Now let's see some possible risks during offshore pipeline decommission. First, personal hazards. Some examples are stuck by moving equipment and caught between moving joints of pipes. To reduce this type of risk, one should wear personal protection equipment (PPE) and always be alert of the risk. The next example is fall from height. To reduce this kind of risk, one should always use fall protection equipment. The next risk is chemical risk. Chemical risks include exposure to hazardous chemicals, ultraviolet radiation, and substances with low radioactive. To minimize this type of risk, one should always wear personal protection equipment (PPE) and be aware of the risk and always be alert. Other risks are related to pipelines that are left in situ for decommission. This pipeline may affect the fishing vessel. To minimize the risk, exclusion zones should be identified. Other than that, these pipelines may affect the marine environment negatively. To minimize this risk, hydrocarbons in the pipeline should be purged and flushed to lower concentration of hydrocarbons in the pipeline. That's all for risk management part. Thank you for watching our presentation.